Right, this is Unit 9, Lesson 2, Circles. Our lesson essential question is, what are the geometric properties of a circle, and how do they relate to algebraic representations of a circle? At the end of this lesson, you'll be able to write, graph, and apply the equation of a circle. Example 1, derive the equation of a circle. How can you write an equation in standard form that describes a circle 2, -1, and radius 3? Recall that a circle is a set of points that are a fixed distance called the radius from a fixed point called the center. It is the cross-section of a cone cut by a plane perpendicular to the cone's axis. This circle is the set of all points that lie 3 units from the point 2, -1. Use absolute value to find the lengths of the legs, since length must be positive. By the Pythagorean theorem, the absolute value of x minus 2 squared plus the absolute value of y minus -1 squared equals 3 squared, or x minus 2 squared plus y plus 1 squared equals 9. Squaring each term eliminates the need for absolute value. The standard form of the equation of a circle with center hk and radius r is the x minus h squared plus y minus k squared equals r squared. Notice that the equation that was given as the solution was expressed in standard form. The equation of the circle is x minus 2 squared plus y plus 1 squared equals 9. All right, let's try it. Write the equation of a circle with radius 1.8 and center at the origin. So we know that in order to write a circle, so I have x minus h squared plus y minus k squared equals r squared. We know that 0, 0 is the origin, so that's where it's centered at, and our radius equals 1.8. Now we just substitute in the values. So I have x minus 0 squared plus y minus 0 squared equals 1.8 squared. Okay, when I simplify this, I get x squared plus y squared equals 1.8 squared. And you can just leave it like that. What would the equation be if the center was at -4, 5? So our radius still stays the same. So now we have -4, 5 and radius of 1.8. So again, I just substitute in. So x minus -4 squared plus y minus 5 squared equals 1.8 squared. So when I simplify this, it's x plus 4 squared plus the quantity y minus 5 squared equals 1.8 squared. Example 2, write and graph an equation of a circle. Write an equation of the circle and sketch its graph. What are the domain and range of the relation? The circle is centered at the origin with radius the square root of 3. So at this point, origin, remember h equals 0, k equals 0, and r equals the square root of 3. I can set it up into my formula, so I get x squared plus y squared equals 3. Remember, the square root of 3 squared just gives me 3. And then I get rid of that pesky square root sign. To sketch the circle, first plot points on the axes that are the square root of 3 units, or about 1.7 units away from the origin. Although this is not the graph of a function, you can determine that both the domain and range of the graph are negative absolute value of, or negative square root of 3, square root of 3. The circle centered at -3, 5 with radius 5, 2. Again, we're finding the domain and range and the equation of the graph and sketching it. So our h is -3, our k is 5, and our r is 5/2. Okay, so we just substitute in these values for h and k. Remember, -3 makes this equation right here, the x minus -3, a positive. So I have x plus 3 squared plus y minus 5 squared, and then 5/2 squared is 25/4. I plot the center, which we were given at -3, 5, and then I plot 5, 2 from the 5/2 units from that center on each of my 4 axes. Okay, so the graph is also not a graph of a function. Again, it's a circle, so it's never going to have, if I have a vertical line, That's what makes it a function. Can pass the vertical line test. I would go through 2 points. But you can determine the domain is negative 11 halves, negative 1 half. So again, this outside and then this outside. And the range is 5 halves to 15 halves. Okay, so again, this bottom point and this top point. All right, let's try it. Find an equation of the circle described. Sketch the graph. So the center is at 0, 0. So here I'm going to put it at 0, 0. And my radius is at 4. So I'm going to bring it into 4. So there's my graph. Drag the points in the graph to set the center and the radius of the circle. So my 0, 0, and my radius is 4. Okay. So when I do this, I'll have x minus 0 squared plus y minus 0 squared equals 4 squared, which is just x squared plus y squared equals 16. For B, the center is 8, negative 3. So we go out a little bit. Okay, so 8 is over here, and then negative 3 is down here. Yep, okay, so 8, negative 3, and the radius is 1. It's a really small circle. Okay. And then my point, my center is 8, negative 3. Radius equals 1. So I have x minus 8 squared plus y. Remember that minus 3 becomes a plus 3 squared equals 1 squared, which is just 1. So x minus 8 squared plus y plus 3 squared equals 1. Okay. So the equation of the circle is x minus 8 squared plus y plus 3 squared equals 1. Or you can actually factor everything out and get x squared plus y squared minus 16x plus 6y plus 72 equals 0. Okay, and then here's my circle, 8, negative 3. All right, example 3. Use a circle to model a real-world situation. A city wants to honor hometown veterans with a new memorial statue in a local park. A grid map of the park shows the statue centered inside a circular fence of radius 5. 2 spotlights are shown at points 2, 2, and 10, 8. So here's 2, 2, 10, 8 on the map. They are at the endpoints of the diameter of the circular fence. What equation represents the graph of the fence on the grid map? Okay, so I know that the center of the graph, the radius is 5. I don't know what the center is, but I do know 2 points. Okay, so to find the equation of the circle, first I find its center. The center of the circle is at the midpoint of the diameter. So x sub 1 plus x sub 2 divided by 2, and then y sub 1 plus y sub 2 divided by 2. So my 2 x points are 2 and 10, and my 2 y points are 2 and 8. So 10 plus 2 divided by 2 gives me 12 divided by 2, which is 6. 8 plus 2 is 10 divided by 2, which is 5. So the center of the circle is at 6, 5 on the grid map. This is where the statue should be placed. Now I write the equation of the circle with center 6, 5 and radius 5, which is x minus 6 squared plus y minus 5 squared equals 25. For B, an information kiosk is planned. One possible location is represented by the point 9, 1 on the map. Should the kiosk be here, or should it be moved so as to not interfere with the fence? Support your answer. So I can substitute 9 in for x and 1 in for y in my equation and solve. So 9 minus 6 squared plus 1 minus 5 squared equals 25. I substitute it all in and simplify. So I get 25 equals 25. So yes, the point 9, 1 is directly in the path of the fence. So the kiosk should be relocated. So that 25 means it's right on the diameter of the fence. So 9, that's 10. So it would be right here along this fence. All right, let's try it. A second information kiosk is planned for the location represented by the point 3, 9. Should the kiosk be moved so as to not interfere with the fence? Recall that the equation that represents the location of the fence is x minus 6 squared plus y minus 5 squared equals 25. So all I need to do is substitute in the values that I have for x and for y. So for x is 3 and y is 9. And I want to see if it equals 25. Remember, if it equals 25, it's going to interfere with the fence. So 3 minus 6 is negative 3. 9 minus 5 is 4. Negative 3 squared is 9. 4 squared is 16. And 9 plus 16 is 25. So yes, the kiosk should be moved as it will interfere with the fence. Example 4, complete the square to find the center and radius of a circle. How can you rewrite the equation x squared plus y squared plus 4x minus 8y plus 4 equals 0 to show that it is the equation of a circle and to identify its center and radius? So I'm going to rewrite the given equation. I'm going to rearrange the terms to keep x and y terms together. So I put my x terms together, so x squared plus 4x, and my y terms together, y minus 8y. And then I move this plus 4, my constant, to the other side. Okay? Complete the squares and add to each side. So in order to complete this square, it's plus 4. For this square, it's plus 16. So then I rewrite the expression as perfect square binomials, so that x plus 2 squared plus y minus 4 squared equals 16. Negative 4 plus 16 is 16. Okay, I express the equation in standard form. So x minus negative 2 squared plus y minus 4 squared equals 4 squared. So my center is negative 2, 4, and my radius is 4. The equation x plus 2 squared plus y minus 4 squared equals 16 shows radius 4 and center negative 2, 4. So I want to verify that x squared plus y squared plus 10x minus 6y minus 2 equals 0 is an equation of a circle. Identify its radius and center. So I'm going to go ahead and rewrite my equation. Now I'm going to group my x's together and then my y's together. So y squared minus 6y. And I'm going to move that negative 2 to the other side. Okay. Now I'm going to go ahead and complete the square for each of these. So, all right, so when I do that, I take half the x term and then I square it. So half of 10 is 5. 5 squared is 25. So x squared plus 10x plus 25 plus y squared minus 6y. Half of 6 is 3, and then squared is 9. So plus 9 equals 2 plus 25 plus 9. Okay, so then I'm going to go ahead. So this is going to be x plus 5 squared plus y minus 3 squared equals 36. Okay, and then from here, I just need to rewrite it, remembering that x minus squared plus y minus 3. There we go. And then 36 is 6 squared. Okay, so that means my point is negative 5, 3, and my radius is 6. Right, example 5, solve a linear quadratic system. What is the solution of the system of equations 3x minus y minus 5 equals 0, x squared plus y squared minus 25 equals 0? I can solve the linear equation for y and substitute it into the equation of the circle. So 3x minus 5 minus y becomes y equals 3x minus 5. I just moved the y to the other side. So when I substitute that 3x minus 5 in for y, I get x squared plus the quantity 3x minus 5 squared minus 25 equals 0. When I expand the perfect square binomial, I get x squared plus 9x squared minus 30x plus 25 minus 25 equals 0. Then I combine my like terms and simplify. 10x squared minus 30x becomes, I can factor out a 10x, and I'm left with x minus 3 equals 0. Factor using the zero product property. So x equals 0 or x equals 3. So 10x equals 0 gives me that x equals 0, and x minus 3 equals 0 gives me that x equals 3. I substitute those values back into my linear equation, and I get y equals 3x minus 5 becomes y equals negative 5, so 0, negative 5. I substitute 3 back in. 3 times 3 is 9 minus 5 gives me 4, so 3, 4. Verify the solutions 0, negative 5, and 3, 4 by substituting the values into the original equation or by graphing the system. Solve the linear quadratic system of equations for 2x plus y equals 3, x squared plus y squared equals 9. So 2x plus y equals 3 can become y equals 3, actually negative 2x plus 3. I'm just going to substitute that in. So that gives me negative 2x becomes 4x squared becomes 2x times 2x gives me the 4x squared. Negative 2x times 3 gives me negative 6x. Negative 6x plus 9 equals 9. Okay. I'm going to move the 9 to the other side. I'm just going to go ahead and combine like terms. 4x squared minus 12x plus 9 minus 9 equals 0. Okay, combine my like terms. Sorry, 5x squared minus 12x equals 0. This gives me values. Background x. I have 5x minus 12 equals 0. So x equals 0 or x equals 12. So I substitute those values back in to the 2x plus y equals 3. So for x equals 0, 2 times 0 plus y equals 3, so y equals 3. And then for 2x plus y equals 3, where x equals 12 fifths, 2 times 12 fifths plus y equals 3. So 2 times 12 fifths is 4.8. 4.8 plus y equals 3. So y equals 3 minus 4.8. So y equals negative 1.8 or negative 9 fifths, whichever. You want to keep it as a fraction, you can. So that gives me 0.03 and 12 fifths, negative 9 fifths. Concept summary. Circles. Definition. A circle is a set of points that are a fixed distance called the radius from a fixed point called the center. The standard form of an equation of a circle with center h, k and radius r is x minus h squared plus y minus k squared equals r squared. I can graph the graph of x plus 1 squared plus y minus 5 squared equals 4. Tells me I have a center of a circle at negative 1, 5. And then I have a radius of 4, so it's 4 units from each of those directions out to that circle. I can also complete the square to express the equation of a circle in standard form. So x squared plus y squared plus 2x minus 10y plus 10 equals 0. I separate all my x values from my y values, and I move my constant to the other side of the equation. I complete the square for each one, remembering that I take half of the x value or the y value, and then I square that. So for example, 2 times 1/2 is 1, 1 squared is 1. 10 divided by 2 is 5, squared is 25. I add those values to the other side, and then I simplify. So this tells me I have a center at negative 1, 5, and a radius of 4. And that is the end of Unit 9, Lesson 2.